Hello there, chemists! This video is designed to take you through some of the features of Microsoft Excel that will reduce time and frustration in your general chemistry laboratory course. These tips are inspired by some of the most popular mistakes and frustrations I saw as a TA for the students in the Chem 102L course. I'd encourage you to open your own Excel file and replicate these steps as we go through this video. In order to avoid confusion, please go to File, Options, Formulas, and uncheck the R1C1 reference style. Now our formulas will look the same. Let's get started. If you collected data inside the Capstone software, you probably exported the data as a file with a type called CSV, meaning comma-separated values. CSV files only hold limited information, so you should change the file type to Excel Workbook before editing the file. Good. Now my changes will be saved properly. In this example, I collected transmittance values for several solutions in a colorimeter. The purpose of this lab was to create a calibration curve and then use Beer's law to solve for the equilibrium concentrations in order to solve for the equilibrium constant. I'll just show you the first few steps. The first table comes directly from the lab manual. It should contain the name of the standard and the volumes of chemicals added. Our standard solutions are made from 1,000 microliters of iron nitrate, variable amounts of sodium thiocyanate, and variable amounts of water. I can carry values forward by clicking and dragging the bottom right corner of the cell. This table is missing something important: units. Rather than putting units next to every value on the table, you should write them in the column headers. This is generally true for all tables. You can find special symbols in the Insert tab of the ribbon. Excel will save you a lot of work if you let it. It has an abundance of functions such as sum, average, standard deviation, and more. It can do fairly complex math. I'll now create a column for the total volume in each cuvette. Start with an equal sign, then type sum, open parenthesis, and click on the cells that should be added. You can separate the cells with commas, or box them all at once. This formula can be carried to each cell like I did before. In order to calculate the concentration of iron thiocyanate, I need to use the concentration of sodium thiocyanate. I'll list this value above the table, but I need to make some space first. There are several ways I can do this. I can insert a row by right-clicking on the row identifier and choosing Insert, or I can select just a few cells, right-click, and click Insert Rows by shifting cells down. Alternatively, I can just select the entire table and drag it to where I want it. Excel automatically adjusts all the cell references. Cool. I used 2 millimolar sodium thiocyanate. The iron thiocyanate is calculated by stoichiometry, with the assumption that all sodium thiocyanate was consumed. Start with the equal sign, click on the concentration of sodium thiocyanate, and multiply that by the volume used. Now we are in moles of sodium thiocyanate. Convert to moles of iron thiocyanate by dividing by 1 and multiplying by 1, and then divide by the total volume of the solution. Push Enter when you are done. Do I have to do this 4 more times? No. We can carry the formula down the rest of the column. But when I do that, it looks like there's an error. When I double-click on the last cell, I can see that the concentration reference moved. There's a way to lock the cell reference. First, click Escape to get out of the cell editor. On the first cell, I'll edit the equation so that it holds the F1 cell reference constant. Do this by pushing F4 on your keyboard, or by typing the dollar symbol before the column and/or the row. Now when the equation is carried down, the F1 cell is still referenced. Now let's include the transmittance values in this table. We performed the measurement in triplicate, so I will include 3 columns for 3 measurements. Keep in mind this is only a proposed method for organizing your data. You can do it the way that makes the most sense to you. I'll merge these cells to make a proper header. Let me make a special note here. it is almost never a good idea to copy and paste values in Excel. In most instances, referencing the cells is better than copying and pasting. I'm going to copy and paste the measured data into our table, but I would avoid doing this for any calculated data. It's also nice, in this case, that I can transpose the data as it comes into the table. I mentioned that Excel can perform many functions. In order to calculate the absorbance, we'll use the log function. Absorbance equals 2 minus the log of the percent transmittance. We obviously shouldn't have 6 significant figures here. In order to change the number of decimal places shown, use these buttons in the Home tab of the ribbon. If you need to, go back and review sig figs for log functions. Okay, we have all the data we need for the standard solutions so that we can create our calibration curve, or Beer's law plot. In this course, you will most likely only use scatter plots. In the Insert tab of the ribbon, click on the Scatter Plot dropdown. There are a few styles to choose from. As a general tip, if you are going to be doing a linear regression and showing the best fit line, choose the scatter plot without connecting lines. Sometimes Excel will automatically add data into the plot. I prefer to add the data manually, so I make sure it's what I want. You can add, remove, or edit the data by clicking Select Data in the Design tab. Our calibration plot should be absorbance versus concentration. Remember that we say the dependent versus the independent variable, or y versus x. An important note here. You may be tempted to just add 3 series for your 3 trials. We want all points to be taken into consideration in the single linear regression. There are cases when you can have multiple series, but this is not one of them. Notice the error I get as I add the data as it is organized in this table. There are a few ways to get around this. I'll show you one. In this case, I will combine the data from all 3 trials into a single column for concentration and a single column for absorbance. Notice that I am referencing the cells instead of copying and pasting. This will help my grader know where I got these values. This data is ready to add to the scatter plot. Again, click Select Data and add a series. Our title will be Calibration Curve for Iron Thiocyanate. The X values are concentration and the Y values are absorbance. It looks like the axes sig figs are correct. If you needed to change them, click on the axis labels, right-click, select Format Axis, and expand the Number section. You can change the values to or from scientific notation and also determine the number of decimals. Let's add axes labels now, either with Add Chart Element in the Design tab of the ribbon, or with this plus sign. Don't forget the units. We'll specify absorbance units just for good measure. Keep in mind that you can add subscript or superscript in the font menu of the Home tab of the ribbon. It's time to add the best fit line and to get the equation of the line. Either with Add Chart Element in the Design tab of the ribbon or this plus sign, add a linear trend line. In the additional options for the trend line, checkmark Display Equation on Chart and Display R² value on chart. Now what about those significant figures? For our purposes in general chemistry, we will just use the same number of sig figs as the x or y values had. Our y-axis had 3 and 4 sig figs, but our x-axis had 3 sig figs. We will change our regression data to have 3 sig figs by clicking the text box, clicking on Label Options, and changing the format to number or scientific notation. That looks pretty good. There's one last thing I want to show you. The equation displayed is a form of Beer's law. Absorbance equals molar absorptivity coefficient times path length times concentration plus some experimental constant. we can plug in any absorbance value and obtain the concentration of iron thiocyanate. Rather than using the rounded values for the slope and intercept, I'll show you how to use the line_st function to get the exact values. Select two cells side by side. Type equals linest, open parenthesis, the y values, comma, the x values, comma, and true, comma, true, close parenthesis. This is an array function, so you have to press Ctrl-Shift-Enter. If you do this successfully, it will show the slope on the left and the intercept on the right. You can then use these values in future calculations and thus avoid rounding. For example, if we measured a solution with an unknown concentration and the absorbance was 1.32, the concentration can be calculated by absorbance minus the y-intercept, all divided by the slope. Line_st is one of the most useful functions in Excel, in my opinion. Well, that's it for this video. Hopefully it will get you a good start to your General Chemistry Lab course. Good luck!